Hi guys, Philip English. I am a robotics enthusiast, reporting on the latest business and application of robotics and automation. So today we've got Slamcore, and we've got Owen from Slamcore, Owen Nicholson, and he's going to give us a quick overview of the technology down there. So Owen's also the CEO and co-founder. And for any of you who haven't come across SLAM before, it stands for Simultaneous Mapping, and I've already got it wrong. Apologies. Simultaneous Localization and Mapping. And Slamcore developed the algorithms that allow basically robots and machines to understand their space around them. So as more robots come out, then they have a sense of where they are, and obviously they can interact with our environment. I thought if Owen, just to give us an intro and an overview really about yourself to start with, Owen, if that's okay.
Sure, awesome. Well, thanks a lot for the opportunity, Phil, and thanks for the intro. So just to play it back, I'm Owen. I'm the CEO at Slamcore. I'm also one of the original founders, and we've been going for about 5 years now. We originally span out from Imperial College in the UK, one of the top colleges in the world, founded by some of the absolute world leaders in this space. And it's been an incredible journey over the last 5 years, taking this technology and turning it into a real commercial product, which I'd love to tell you about all today.
Right, thank you for the overview. And so you were saying that obviously you're one of the co-founders. So I was on the website. So is it four main co-founders? Or?
So yes, two academic co-founders, and then two full-time business founders as well. So from the academic side, we have Professor Andrew Davison and Dr. Stefan Luthenegger. Between them, they're two of the most respected academics in this space. Probably most notably Professor Davison, who is one of the original founders of the concept and the real pioneers of SLAM, particularly using cameras. So we'll tell you more about that. But this is really our particular flavor of SLAM, is using vision, and he's been really pushing that for the last nearly 20 years now. So incredible to have him as part of the founding team. And then Dr. Luthenegger, who's now at Technical University Munich, who is another one of the real pioneers of vision for robotics. And then myself and Jacek, we're the full-time business side of things when we founded the company.
Right, fantastic. So you've got quite an international sort of group of co-founders there. It sounds like you've got some, obviously, from an academic point of view, a team that have been studying this and doing this technology for years. So that's really interesting.
Absolutely, and it's one of those things when you start with strong technical founders, then you can attract other great people into the space. So one of our first hires was our CTO, Dr. Pablo Alcantara, who came from iRobot. So great to be able to bring someone of that quality in, and he's another one of the absolute real leaders in the space, but also with the real experience in industry. So he's been at Toshiba, he's been in iRobot, and knows all about how do you get this stuff to work on low-cost hardware in the real world, and at a price to performance point that really makes sense. And we've now reached our 33rd hire. So it's been incredible. And we've got still a big technical team, about 18 PhDs, I think, still. About 3/4 are still technical. So they either have a PhD or an extremely in-depth experience in software engineering, and particularly embedded software engineering. But we're also growing out our commercial and business side of the company as well over the last year and a half.
Right, fantastic. Yeah, it sounds like a phenomenal sort of growth over the 5 years to have such a strong team there. And we were chatting before. So obviously you're based down in Borough in central London, but you've also got another branch a bit out in whereabouts was it again?
Chiswick. So kind of West London. So we have a couple of offices for the team to work from. We have, I think on the last count, 17 nationalities now represented within the company. So we sponsor a lot of international visas. We bring a lot of people into the UK to work for Slamcore from all over the world, most continents represented now. But I think this is just the way it goes. The type of tech we're working in is is very specialist, and we need the best of the best. So it's the challenge is these guys can go off and girls can go off and work in DeepMind or Oculus if they wanted to. So we need to make sure that we attract them and retain them, which is something we've been very successful with so far.
That's right, and it's all about getting the best team around you, like a sports team. You know, you want to get the best, the best players, to do the work. I mean, how did you find your, obviously the team that started? Do you sort of regularly advertise, or do you do a bit of headhunting for the guys you got?
It's a mixture of both. Having great people from the founding team means we can get we've got good access to the network. So we do have a lot of inbound queries coming in for. We have very rigorous interview processes, but we use recruiters, we use headhunters, particularly for some of the more commercial hires. We've used kind of high-end headhunters to find these people, because they're very hard to find. Once you do, then bringing them in, it needs to be. We need to make sure that it's a vision they really buy into. So that's we have a multiple ways in which we've attracted people over the years, but I'd say because we have such a good quality team, it attracts other great people. So it's one of the real benefits.
That's right. Sort of talent attracts talent, and obviously those are the sort of guys who are likely to know each other, like within the space as well. And like you mentioned vision there, and we'll get into vision a bit later on. But I suppose I'm interested in the problem or the issue to start with. I mean, could you talk around, obviously, I suppose the fundamental problem that you guys are trying to address?
Sure. So I think at the heart of it, we exist to help developers give their robots and machines the ability to understand space. Quite high level, but let's start there. And ultimately, we break this down into the ability for a machine to know its position, know where the objects are around them, and what those objects are. So its coordinates, its map, and is it a person, is it a door? Those are the three key questions that machines, and particularly robots, need to answer to be able to do the job that they've been designed for. And the way this is done normally is using the sensors on board the robot, and combining all these different feeds into a single source of truth, where the robot creates essentially a digital representation of the world, and tries to guess where it is within that space. And the problem has always really been that actually the number one cause of failure for a robot isn't the wheels falling off or it falling over, although there are some funny videos on the internet about that. Actually, when it comes to real hardcore robotics development, the challenges that are faced are mainly around the discrepancies between the robot's understanding of the space and its reality. So that's what causes it to crash into another object. It's what causes it to get lost on the way back to the charging station, and therefore not actually get there in time, so it runs out of juice and just dies. So the high level problem we are trying to address is giving developers the ability to answer these questions without having to be deep experts in the fundamental algorithms that allow you to do that, because there's an explosion of robotics companies at the moment, and it's super exciting seeing all these different new applications coming out, really driven from lower cost hardware coming out and modular software, which allows you to quickly build POCs and demos and early stage prototypes. But there's still, when you really drill into it, probably well over 90% of those machines today will not scale to a commercially viable product as it stands if they literally went and tried to sell that hardware and that software right now. So this is where most of the energy is being focused on by the companies, trying to modify what they have to be more accurate, more reliable, or reduce the cost. And actually nearly most of the time it's all three. So they're nearly always trying to make it increase the performance and reduce the cost. And this is phenomenally time consuming. It's very expensive. It can be, because it's lots of trial and error, especially if you have a robot where, say, a service robot where you need to shut down a supermarket to be able to even do your testing. You might only get an hour a month to be able to do that with your client. And this is such a critical time. And if you spend the entire time just trying to get the thing from A to B, not actually worrying about what does it do when it gets there, this is really what's holding back the industry as a whole.
Right, I see. So if I'm obviously like a manufacturer and I want to build a solution again for like retail or education or even hospitals is quite a good one, then basically Slamcore is one of the components that I can bring into the product that I'm building. And again, it's got all the expertise, it's got everything it needs to make sure it does a brilliant job on the vision side. So the one, obviously, that helps with costs on manufacturing on a new product, and then it's easier for the customer to launch the product knowing that it's got a branded and obviously a safe way of localization.
Absolutely. It's that time to market for a commercially viable system. So you can build something within a month. In fact, at the end of Masters projects, you quite often will have a robot which is able to navigate and get from A to B, but doing it in a way which, especially when the world starts to get a bit more chaotic, that's probably the real challenge, is when you have people moving around, structures changing. The standard systems today they just don't work in those environments. They don't work well enough to, especially when you have 100, 1,000, 10,000 robots. If your mean time between failure is once every 2 weeks, that's okay for your demo, but it doesn't work when you've got 10,000 robots deployed across a wide areas. So, yeah.
Yeah, well, this is it. I mean, from what I've seen, it's all about movement, and as you said, like you can do a demo with a robot, sort of show it working in an environment that's half empty and no one's really around. But once it's a busy environment, busy retail, lots of people, lots of movement, and it's very easy for, obviously the robot can get confused and saying, "Oh, is that a person? Is that a wall? Well, you know, where am I?" Sort of thing, and then that's it. It loses its localization, and then you're stuck. So I suppose the question I had was around the technology. So I saw on one of your videos, obviously you were using one of the Intel cameras, but can you link it with sort of any laser scanner, any LiDAR scanner? Is there a certain tech product range that you need to integrate as well for Slamcore to work best? Or?
Absolutely, great question. I think this is one of the really interesting when does a technology become a commercial product questions, because the answer is if you lock down the hardware and you work just on one specific hardware sensor combination, then you can build a system which works well, particularly with vision. So you don't, if you look at some of the products out there already, Oculus Quest, I know it's not a robot, but ultimately it's answering very similar questions. Where is the headset? What are the objects around it? Same with the HoloLens, the iRobot Roomba, and a number of other questions. They've all successfully integrated vision into their robotic stacks, and it works. They work very well on low cost hardware. The challenge has been then if you want to then if you don't have those kind of resources, if you're not Facebook or Microsoft or iRobot, so then you have to. A lot of the companies are using much more open source solutions, and they quite often use laser-based localization. Is the very common approach in this industry, and we are not anti-laser at all. LiDAR is an incredible technology, but you shouldn't need a $5,000 LiDAR on your fleet of robots. Just for localization. And that's currently where we are in this industry. The reality is there are cheaper ones, absolutely, but to get ones that actually work in more dynamic environments, you need to be spending a few $1,000s on your lasers. So at the heart of our system is we process the images from a camera. We extract the spatial information. So we look at the pixels, how they flow, just to get the sense of geometry within the space. So this gives you your coordinates. It gives you the surface shape of the world. So your floor plan and your where are the obstacles, irrelevant of what they are, but what if there's something in my way, and that's kind of the first level our algorithms operate at. But then we also are able to take that information and use our proprietary machine learning algorithms to draw out the higher level spatial intelligence, which is the object names, the segmenting them out, looking at how they're moving relative to other parts of the environment, and that all means that we're able to provide much richer spatial information than you can achieve with even the high end 3D lidars that you have available today. Just to address your question directly, as far as portability between hardware, this is one of those real challenges, because if we'd have decided 3 years ago to just lock it down to one, so the Intel RealSense, it's a great sensor, they've done a really good job. And if we'd have just decided to work with that and optimize only for that, today we would have something which it's extremely high performing, but you wouldn't be able to move it from one product to another. If another sensor was out there at a different price point, it wouldn't port. So we've spent a lot of our energy taking our core algorithms and then building tools and APIs around them so that a developer can actually integrate into a wide range of different hardware options using the same fundamental core algorithms, but interacting with them through different sensor combinations. Because the one thing we know in this entire industry, there's a lot of unknowns, but probably the one thing we all know is there's no one robot which will be the robot that works everywhere. Just like in nature, there's no one animal, although as an aside, nature uses vision as well, so there's clearly some benefits there. Evolution has chosen vision as its main sensing modality, but we need variety, we need flexibility, and it needs to be easy to be able to move from one hardware configuration to the next, and that's exactly what we're building at Slamcore. Our approach at the moment is to optimize for certain hardware. So the RealSense right now is our sensor of choice, and it works out of the box. You can be up and running within 30 seconds with a RealSense sensor. But if you come along with a different hardware combination, we can still work with you. It might just need a bit of porting, but we're not talking blue sky research. We're talking a few weeks of drivers and API design to get that to work.
Right, fantastic. And I suppose every year you also get a new version of a camera like coming out as well. So a new version of the Intel RealSense, which would obviously, it's normally advanced version and it's better version. And then obviously, I suppose that helps with your three key levels, which is what I just wanted to quickly go over, because obviously, like, you discussed them there. So I saw you had three levels. There was tracking, mapping, and the semantics. So that's basically what you were saying. So obviously, your algorithm stage then is that level 3? Is that the semantics, or is that level 2? I'm confused.
So we actually we call it full stack spatial understanding. So we actually we provide the answers to all three, but within a single solution. And this has huge advantages because there's performance advantages, but there's also you're not processing the data in lots of different ways, and it means you can answer these questions using much lower cost silicon and processors, because you are essentially building on top of each one, so each one feeds into the next. So, for example, our level 1 solution is tracking, gives you very good positioning information, and then our level 2 is the shape of the world, but we can feed the position into the map so that you get a better quality map, and then we can feed that map using the semantics to identify dynamic objects and remove them before they're even mapped, so that you don't confuse the system, and then this actually improves the positioning system as well, because you're no longer measuring your position against things which are non-static. So there's this real virtuous circle of taking a full stack approach, and it's only really possible if you understand the absolute fundamental mathematics going on, so that you can optimize across the stack and not within your individual elements across it.
Wow. Okay. And then within the algorithm package, then is it a constantly learning system? So obviously, if we've developed like a mobile trolley to go around a factory, and someone puts a permanent post there or a permanent obstacle, will it learn to say, okay, that obstacle is there now, and we'll include that into the map?
It's absolutely that's one of our core features, which is what we call lifetime mapping. So currently with most systems, you would build your map. This is how a lot of the LiDAR localization works. You'd build a map with essentially a master run. You'd save that map, maybe pre-process it to get it as accurate as possible. And that becomes your offline reference map off which everything localizes against. So right now we provide that functionality today, but using vision instead of LiDAR. So you already get a huge amount more tolerance to variation within the scene, because we are tracking the ceiling, the floor, the walls, which are normally a lot less likely to have changes. So even if that post appeared, it wouldn't actually change the behavior of the entire system. But we are also later this year we'll be updating our release to be able to merge maps from different agents and from different runs into a new map. So every time you run your system, you can update it with the new information. And this is something which is very well suited to a vision-based approach, because we can actually identify, okay, that was a post. Probably more interestingly, maybe a pallet or something where a pallet gets stuck in the middle of the warehouse. And you don't want to, maybe during that day, you want to communicate to the fleet that there's a pallet here. So you don't want to plan your path through it. But the next day you might want to remove that information entirely because it's unlikely to still be there. So we ultimately don't provide the final maps and the final systems. We provide the information that the developers can then use. They can use their own strategies, because this is key. Some applications might want to know and keep all the dynamic objects in their maps. Some might want to ignore them entirely. So we really just provide the location, the positions of those objects in a very clean API, so that people can actually use it themselves.
Right, I see. And then, and when you said sort of an emergence of other mapping tools. So I've seen the old classic where you have like someone who has a laser scanner on like a pole, and then he's walking around the factory or walking around the hospital to create a 3D map. And then so can you take that data and merge it in with your data to get like a more like accurate map? Is that what you mean? Or?
At the moment, not we don't fuse maps created from other kind of systems like it into our system. We ultimately would want to consume the raw data from that laser and fuse it into our algorithm. So right now, our support is for vision, inertial sensors, and wheel odometry. LiDAR support will come later in the year. It's just a matter of engineering resource at the moment. Algorithmically, it's all supported, but from a engineering and API point of view, that's where a lot of the work. It's that last 10%. A lot of people will tell you about is quite often 90% of the work. I know it's meant to be 80-20, but I think in robotics, it's more like 90-10. And so we wouldn't support that sort of setup at the moment. But the answer is you shouldn't need to do that, because with those systems you need to be very accurate quite often. Be careful how you move the LiDAR. Also, you need a lot of compute. You also need to do it quite often offline post-processing. Whereas our system is all real time. On the edge, it runs using vision, and you can build a 3D model of that space all in real time. Actually, see it being created in front of you on the screen, so that you can actually go back and I missed that bit. I'll scan there. So this is really a kind of a core part of our offering.
Right, fantastic. I suppose the last question I have in regards to the solution, then, which is obviously what you've been going through, which is fantastic, is so is this just for internal, or can you go external as well? I mean, I've seen SLAM-based systems have issues with things like sunlight and rain and weather conditions. Is it internal at the moment, and then it looking to go external eventually, or whereabouts does it sit?
We tend not to differentiate internal, external. It's more to do with the type of environment. So as long as we have light, so we won't operate in a lights off factory, because we need vision. And as long as the cameras are not completely blinded. So the rough rule of thumb we normally say to our customers are, could you walk around that space and not crash into things? If the answer to that is yes, then we may have to do some tuning for some of the edge cases around auto exposure and around some of the way in which we fuse the data together. But we already have deployments in warehouses which have large outdoor areas and indoor areas, so they're transitioning between the two. We are not designing a system for the road or for city scale autonomous car SLAM, which really is a different approach you would take, and that's where a lot of those more traditional problems you just talked about, rain and those types of areas, really start to become an issue. But for us, we support indoor, outdoor, whether it's a lawnmower or a vacuum cleaner, the system will still work.
Right, fantastic. Yeah, and I think this is it. I mean, we're starting to see a lot more outdoor robots come on the market, probably more over in the US, but obviously that's going to be the future. So obviously, yeah, like the whole market's there. And I suppose it sort of leads on to the bigger sort of vision for you guys then. I mean, like where do you see the company in like 5 years' time, and like technology-wise, I suppose, and what's the ultimate goal? I suppose to get perfect vision, like similar to like a human's vision. I quite liked your animal like analogy there, actually, because obviously vision is one of the core things. But I suppose what's the why for you guys and the next sort of steps?
Yeah, I think really we founded the company because the core technology being developed has so much potential to have a positive impact on the world, and it's essentially the ability for a robot to see, and that can be used for so many different applications. So the challenge has always been doing that flexibly, whilst keeping the performance and cost at a price that makes at something that makes sense. And we're now demonstrating through our SDK. So we actually, the SDK is publicly available if you request access, and you're able to download it. We already have over 100 companies running it, and we'll have about 1,000 companies in waiting as we start to onboard them. So we've demonstrated that it's possible to deliver this high quality solution in a flexible and configurable way. And this means we are essentially opening up this market to people who maybe in the past would not have been able to get their product to that commercial level of performance to be successful. So having a really competitive but also collaborative ecosystem of companies working together, trying to identify new ways to use robots is got to be good for us as an industry, because if it's just owned by a couple of tech giants or even states, then that's going to kill all of the competition. So and this will drive some of the really big applications for robotics we see in the future. In 5 years' time, I believe there will be robots maintaining huge renewable energy infrastructures at the scale which would be impossible to manage with people driving around machines, and looking at sustainable agriculture in a way which means that we can really target water and target pesticides, so that we can really feed the world as we start to grow. And yeah, you've seen all of the great work going on Mars with the rover up there now with Perseverance, and we're using Visual SLAM. Ultimately, it's not ours, unfortunately, but in the future, we would like our system to be running on every robot on the planet and beyond. That's really, really where we want to take this. And it has to be, we have to make sure that these core components are available to as many people as possible, so that they can innovate and they can come up with those next generation robotic systems, which will change the world. And we want to be a key part of that, but really sitting in the background, not living vicariously through our customers. I quite often say I want Slamcore to be the biggest tech company that no one's ever heard of, and having our algorithms running on every single machine with vision, but never having our logo on the side of the product.
Yeah, well, this is it, and this is the thing that excites me about like robotics and automation. I mean, if you think about the IT industry, obviously you have a laptop, you have a screen, and you have a computer. Obviously, there's lots of big players, but you're pretty much getting the same thing. But with robotics, you're going to have all sorts of different technologies, different mechanical, physical machines, and it's going to be a complete mixture. And I mean, some companies will build things similar to do one job, where you may have different robots for different jobs. And yeah, no, I think that sounds great. I mean, obviously, if you've solved that vision issue that we have, it makes it a lot easier for startups, and a lot easier for businesses to take on the technology, get the pricing down, because obviously, if you don't want robots costing hundreds of thousands of pounds, you want them at a level where they're well priced so they can do a good job and actually in the end help us out with whatever role that the robot's doing. So yeah, no, that sounds really, really exciting actually. Yeah, I'm looking forward to keep an eye on you guys. I mean, what's the best way to stay in contact with you then? I mean, what's the best way to get in contact?
Genuinely head to this website and click on the request access button if you're interested in actually trying out the SDK. We're currently in beta rollout at the moment, focusing on companies with products in development. So if you are building a robot and are looking to integrate vision into your autonomy stack, then request access. We can onboard you within minutes. It's just a quick download, and as long as you have a hardware we support today, you can run the system. We have a mailing list as well where we want to just keep people up to date as things as exciting announcements come, and that's really probably the best way is just to sign up to either our mailing list or our waiting list.
Right. Perfect. Thank you, Aaron. And what I do, guys, is I put a link to all the websites and everything, and and some more information about Slamcore. So it was great. It was a great interview, Aaron. Many thanks for your time, and I'm looking forward to keeping an eye on you guys and seeing your progression. So thank you very much.
Watch this space.